In this video, we're going to talk about 3D printing, one of the marvels of modern manufacturing. There are a few technologies of 3D printing that are most commonly used. In my opinion, probably the three most common are SLA, or stereolithography, SLS, or selective laser sintering, and FDM, or fused deposition modeling. I'll talk about each of these three just a little bit. I won't go too far into them, but SLA produces a very fine surface finish. The parts come out looking beautiful, very smooth. They do have a tendency to be a little bit on the brittle side, maybe a little bit weaker than some of the other technologies as far as strength, but materials are always improving, and you know, that's becoming less the case as time goes on. Selective laser sintering, SLS, is it starts off as a powder, and a laser actually sinters this powder or kind of fuses it together, and you end up with a part that is very strong, and strong relative to 3D printing anyway. It's not as strong as like a metal part, but a relatively strong 3D printed part. The surface finish is a little bit on the rough side, so it's not a great process to use if you're looking to make something that's really smooth and you know, nice to touch. The surface finish is not going to be representative of what you might achieve like injection molding or even machining, really. And then the last one, FDM, is maybe the most common 3D printing technology. This is what you'll see on 3D printers like MakerBot. Those are kind of the more consumer grade platform, but the industrial forms of those FDM printers, they work off the same basic technology. There's a head that extrudes a heated filament out of it and places it down layer by layer. And FDM parts are pretty strong. They certainly can be. And they have also kind of a rough finish, but not rough in the same way as SLS. The finish on FDM parts, you can see like each layer, each line that was built by the part. Since all 3D printing is printed layer by layer by layer, you can really see those layer lines in the FDM technologies. So anyway, those are kind of the three most common 3D printing technologies.
What would you tell us about when in the engineering process 3D printing is usually used?
Great, yeah, great question. 3D printing is spectacular for doing prototypes. It is not a high volume manufacturing process. It's not even a moderate volume manufacturing process because they take a long time to create. The 3D printing process builds layer by layer by layer, and it takes, you know, many hours usually to create a part. So it's a slow process. It's not a very expensive process though. You'll usually pay less for a 3D printed part than you would a machined part. So there are some cost advantages when you're making just a low quantity of parts that you really just want to evaluate. These usually aren't parts that you're going to be using ultimately in your final application. They're typically parts that you're just going to be evaluating. You want to make sure the shape is correct and it feels okay in your hands and it fits together with mating components. Those are all great reasons to use 3D printing. There was one other thing I was going to talk about. What was it? Can't remember now. I lost my train of thought.
I have a question for you though. If 3D printing is usually to evaluate a part, then why should one use SLA with the excellent surface finish? Why would the surface finish even matter if we're just evaluating the part?
It might not. It's really up to the designer. If surface finish doesn't matter, then you don't need to use it. SLA parts are maybe a little bit more expensive than FDM or SLS, but not by a great margin.
And why don't you tell us more about 3D printing for metals? Here we have a part.
Yeah, 3D printing for metals is is up and coming. It's nowhere near as common as 3D printing plastic parts, but it is possible to 3D print metal parts. They're pretty expensive, but there are some applications for which it just makes a lot of sense to do that. Turbines for the blower industry or things like that. These processes that it's very difficult to create these shapes any other way. Metal 3D printed parts can be a great solution there. So it's not real common right now, but it's becoming more common.
Why don't you tell us a little bit more about this part? How much, so that the students get an idea, how much was this part to produce?
You know, I'm not sure. Maybe, this is really a guess. Maybe it's $500. I don't know.
Okay. I think it's, being personal, I think it's super cool that you can 3D print metal parts.
Oh, one other thing to talk about in regards to 3D printing is the speed with which you can get parts. And that is a huge advantage when you're prototyping things. The product development process is a lengthy process. It just takes a lot of time. So anything we can do to speed up that process is going to be really valuable. And utilizing 3D printing technologies is one of those things. If you were to have a part machined to produce a prototype, you're probably going to be waiting anywhere from 1 to 3 weeks before you get that machined part back. Whereas 3D printing, you're waiting more like 1 to 3 days. So it really speeds up the process. And if you don't need a part that's really strong, you know, that's going to hold up to heavy abuse or something like that, you're just mainly evaluating the geometry, and maybe there are some functional features in there. Maybe there's a little snap hook or something like that. 3D printing is just, you can't beat it. It's a great process.
Do 3D printing machines ever stop working or have malfunctions?
Sure, just like any piece of machinery, 3D printing machines can break down. The higher end machines, the industrial ones that cost, you know, $50,000, $100,000, those are pretty darn reliable, and they don't break down often. But, you know, like any piece of machinery, they can go down. If you found this content helpful, consider enrolling in our signature program at mypipelineacademy.com. Whether you're an individual interested in beginning a new career as a mechanical designer or a company interested in training your new engineering hires, our signature program helps students develop the practical skills they need to be productive mechanical design engineers. Seating is limited. We hope to see you there soon.